Google built WebRTC for us in Chrome. Time to see how they themselves use it inside their own service, Google Meet. So this is a call that I did with you, one-on-one call over Google Meet with screen sharing.
Yes, and it's a call that gets relayed via the server, with the SFU, and we see some typical quirks of Google Meet here. For example, we have one of the observations, which is basically incoming audio is silent. Yes, it is, but for Google Meet, that's normal and expected.
Mm-hmm.
Yes, no volume on incoming audio, this one.
Yep. Okay.
Can you scroll down? Scroll up a little. No, what I want to see is on a different tab. Please go to connections. Okay, so we have two connections. One is for audio and video. Second one is what Google Meet does for screen sharing. So they always use a second peer connection for outgoing screen sharing. Probably bandwidth estimation reasons.
Okay. Now, we noticed this nice thing here that the timing are really, really low.
Yes, I mean, the time between eyes checking and getting connected is 5 milliseconds, which is roughly the round trip time. We will can see that later, I think, in the streams. Or, no, we can do it down. And the time to get from connected to detail as connected is actually shown as 0 milliseconds. I had to check, and it was 5 thousandths of a second. So the display is correct, but it's too low to be shown.
Yep. Okay.
Yes. The latency, it's an IPv6 connection. What I see typically these days, latency is super low, is 10 milliseconds. So that's the benchmark, basically.
Okay, and they had here half a millisecond, and we thought it was a bug before actually going and checking. The number seemed like unreasonable.
Yes.
Okay. Let's go to streams.
Yes, we see something that's very common for Google Meet. We have Opus, and we have the 3 incoming Opus streams, if I count correctly. Outgoing bitrate is 30 kilobits per second. Doesn't look like DTX is used. Incoming video, you see that first. I think it's simulcast, but it's only using a single stream because it's one-on-one, so actual simulcast doesn't make sense. Later, we have the second connection, which adds basically screen sharing, and that gets used for that.
Yes, and a few differences. It's only 2 incoming Opus streams. So my guess is that one of them is just... No, the other one is actually here only when the video starts.
Interesting.
And then this is VP9. This is the video called the webcams, and he decided to go to VP8 for the screen share itself.
Yes, that is still very common. Nobody likes VP9 for screen sharing for some reason. It's either VP8 or AV1.
Okay.
Okay, lots of data channels, basically one for each kind of message, which is like, you can either use a single channel, put JSON into it with a type flag, or you can use different channels.
Yeah.
This is probably the better method, I would say.
Okay. And then anything in the logs worth mentioning?
Well, the usual SDP munging. Google Meet is still a big fan of SDP munging. And everybody else is doing it because Google Meet does it.
Okay.
Yes, they even add a RTP header extension, even though me and a Google person shipped an API for that. It's like, do you talk to your internal people? No.
Okay. So that was Google Meet and how Google is using WebRTC themselves. If you want to learn more about other services and how they work, or if you want to check, debug, and monitor your own application, come check us out at rtcstats.com.